There, so we're going to just do a quick experiment with capacitors in this one. So the capacitors come in three main types. So these are ceramic, these are called polyfilm capacitors, and these are called electrolytic. That is the kind I have. I'll show you that in a second. So then tearing this apart, it's really simple. What's inside here, it's actually just a bunch of paper really wound in like some thin layers of metal, and that's it for in terms of what's in there. This is this electrolytic capacitor that I have. It has a positive, a longer end, and a negative end, just like an LED does. And my understanding is that it's important that you hook these up in the right direction, because I guess it's possible to destroy these if you hook them up backwards. I did not want to try that out. But what capacitors do is they're like one step lower than a battery. They can't produce new electrons, so they can't produce new power, but they can store power. So you can store electrons in them, but you can't make them. So anyway, let's just take a look here. This is like the same circuit that we had before, and like where these things go. And I think I still have a question about like why. So the capacitor doesn't go in our loop. So here we have our loop around, right? We go from positive, we go through our resistor to the positive end of the LED. The power is going to have to go through the LED, and then it comes back around. That's what we had in the original circuit. And then the capacitor is going to kind of sit across here. So the negative end is going to be over here. The positive end is going to be over here. So it's going to kind of straddle our circuit like this. So I'm going to go ahead and put this in. So I'm going to move this up so you can see again. But I did, knowing that we were going to do this, I left an extra kind of opening here in row 2 right before my resistor. I've got everything else is occupied here. So my LEDs here, my 2 prongs of my resistor, but then I have this opening there. So I've got my positive part of my circuit, and right in that positive portion, right near my red, I'm going to plug in the long end of the capacitor. And then the negative end is going to go over here along the negative portion of my loop. So hopefully that diagram was right. Remember, this is the first time I've ever drawn a circuit diagram or even seen one in my life. So, okay, so there it is. It's in there. Now, so what should we see that's different when this thing is hooked up? Actually, nothing at first. So we shouldn't see anything. We should see the LED light just like it normally would. But the difference is that now some of that power is being stored in that capacitor as that circuit runs. So before, when we unhooked the battery from the circuit, the LED just died. Now, when I unhook the battery, we should see it kind of glow for a while as the stored power in this capacitor runs out. Okay. All right. So let's give this a try and see does it work. So I'm gonna hook this up. My negative is already hooked up, and this is effectively my switch. And so I'm gonna turn this on. So now I'm just running it normally. I'm gonna let it run for a little bit, and it should charge this capacitor. I was doing a little investigation into this, and it's Leyden jar. That's really kind of what this thing is. If you remember that from science, that's essentially what is going on here. They show you, there's a Make magazine video where they talk about how to make one from a film canister and then charge it with static electricity. It's pretty cool. So at any rate, though, all right, look, I've let that charge long enough, I think, and I'm just going to undo this now. And so I did, and now you can see, though, it didn't go off right away. it's kind of flickering out. It's like a campfire there that is going out as the fuel is being spent. And there it goes. It's still a little bit lit. And I think that's it. Okay, so cool. And all right, that's what a capacitor is. And that was our experiment with a capacitor.